Welcome to today's video on the fascinating topic of tunnel diodes. Have you ever heard of this unique type of diode that can exhibit negative resistance? In this video, we'll delve into the science behind tunnel diodes, explore their unique properties, and learn about their applications in various fields. Whether you're a student, hobbyist, or simply curious about the inner workings of electronics, this video is for you. So, sit back, relax, and let's dive into the exciting world of tunnel diodes. Who discovered tunnel diode? Tunnel diodes were first discovered in 1957 by Leo Esaki, for which he was awarded the Nobel Prize in Physics in 1973. How is tunnel diode different from other diodes? It is a semiconductor device that exhibits a unique characteristic called negative resistance. That means, as the voltage increases, current decreases across the diode. Why is tunnel diode preferred? Its ability to operate at very high frequencies, low power consumption, and fast switching times. Symbol of tunnel diode. The circuit symbol of tunnel diode is shown in the figure. In tunnel diode, the p-type semiconductor act as an anode and the n-type semiconductor act as a cathode. How tunnel diode works. 1. Tunnel diodes consist of heavily doped p-type and n-type semiconductor materials sandwiched together, with an extremely thin depletion region between them. 2. When a voltage is applied, electrons can tunnel through the depletion region, resulting in a negative resistance effect. 3. The negative resistance effect is due to the quantum mechanical phenomenon of tunneling, which allows electrons to overcome a barrier they could not under classical physics, and as voltage increases, current flow decreases due to more electrons tunneling through the depletion region. In electronics, tunneling means a direct flow of electrons across the small depletion region from n-side conduction band into the p-side valence band. The germanium material is commonly used to make the tunnel diodes. They are also made from other types of materials such as gallium arsenide, gallium antimonide, and silicon. Width of the depletion region in tunnel diode. The depletion region is a region in a p-n junction diode where mobile charge carriers, free electrons and holes, are absent. Depletion region acts like a barrier that opposes the flow of electrons from the n-type semiconductor and holes from the p-type semiconductor. The width of a depletion region depends on the number of impurities added. Impurities are the atoms introduced into the p-type and n-type semiconductor to increase electrical conductivity. If a small number of impurities are added to the p-n junction diode, p-type and n-type semiconductor, a wide depletion region is formed. On the other hand, if large number of impurities are added to the p-n junction diode, a narrow depletion region is formed. In tunnel diode, the p-type and n-type semiconductor is heavily doped, which means a large number of impurities are introduced into the p-type and n-type semiconductor. This heavy doping process produces an extremely narrow depletion region. The concentration of impurities in tunnel diode is 1,000 times greater than the normal p-n junction diode. Applications of tunnel diodes. Tunnel diodes have a number of applications, including oscillators. Tunnel diodes can be used to generate high-frequency signals for use in electronic oscillators. Amplifiers. Tunnel diodes can be used as amplifiers in certain applications, such as microwave amplifiers. Logic circuits. Tunnel diodes can be used in digital logic circuits, where their negative resistance effect can be used to create bistable circuits. Voltage-controlled oscillators. Tunnel diodes can be used in voltage-controlled oscillators, where their negative resistance effect can be used to tune the frequency of the oscillator. In addition to these applications, tunnel diodes are also used in other electronic circuits such as switching circuits, pulse generators, and frequency multipliers. Now let's talk about advantages and disadvantages of tunnel diodes. Advantages of tunnel diodes include high switching speed. Tunnel diodes can switch on and off very quickly, making them useful in high-frequency applications. Low power consumption. Tunnel diodes consume very little power, making them useful in low-power applications. Small size. Tunnel diodes are typically very small and can be integrated into other electronic components easily. Simple construction. Tunnel diodes have a simple construction that makes them easy to manufacture. Disadvantages of tunnel diodes include temperature sensitivity. The negative resistance effect is highly temperature dependent, so the performance of tunnel diodes can be affected by changes in temperature. Limited operating voltage range. Tunnel diodes have a limited operating voltage range, typically between 100 MV and 1 V. Limited operating temperature range. Tunnel diodes can only operate within a narrow temperature range, typically between -50 degrees Celsius and 100 degrees Celsius. Limited current carrying capacity. Tunnel diodes have a limited current carrying capacity, typically around 100 milliamperes. To conclude, tunnel diodes are a type of diode that exhibit negative resistance, making them useful in a variety of applications such as oscillators, amplifiers, and logic circuits. They have some unique advantages, such as high switching speed and low power consumption, but also have some limitations, such as temperature sensitivity in limited operating voltage and temperature ranges. Overall, tunnel diodes are an important component in many electronic circuits and have played a significant role in the development of modern electronics. Thank you for watching. Credits.